I'm Jai Singh, Emeritus Professor of Physics at CDU. I've been working on solar cells for more than 40 years. My group has produced 8 PhD students and 40 master's thesis students. We have published more than 250 research articles. My current research focus is on organic solar cells and light-emitting devices. These solar cells are very easy to fabricate, so very cost-effective. And these organic devices can be painted on curtains, so in the daytime they generate electricity and light house at night. My current 2 PhD students are Kiran and Daniel, and my former but recent PhD students are David and Human, who are now faculty members at CDU.
The conventional solar cells that are commercially available nowadays are made up of inorganic semiconductor materials like silicon, germanium, etc. So they are called inorganic solar cells. They have power conversion efficiency up to 44% under laboratory conditions. But the commercially available ones have power conversion efficiency around 20%. But the problem is they are very expensive. Hence, the initial cost for setting up these solar panels are very high. For the past few decades, researchers have been focusing on developing highly efficient, cheap, flexible organic solar cells. The beauty of organic solar cell is that when they enter the commercial space, they will help reduce the cost of tapping solar energy.
Organic solar cells have a huge potential to become the next generation photovoltaic technology due to the many advantages, such as low cost, easy fabrication technique, large-scale production, and compatibility with flexible substrates. This makes it possible to apply organic solar cells on basically any surface. The power conversion efficiency of organic solar cells has risen from 5 to 17% within the last decade. Researchers are working to improve on the stability. This is a huge development, and it means that people will start seeing these types of organic solar cells in the market in the near future.
In this research, the primary focus is to improve the power conversion efficiency and stability of organic solar cells. The quantum dots improve the solar absorption, and the nanowires improve the charge transport inside the solar cells. The motif structures on top of glass reduces the reflection losses, thereby improve the absorption efficiency and in turn increase the power conversion efficiency. The problem of stability is studied by analyzing the factors that are responsible for the degradation of the organic active layer.
We hope and expect that in the near future we can expand our solar cell lab to attract more students from all around the world to study in CDU and do research in this important field.
Other solar cell types include dye-sensitized, perovskite, quantum dot, and nanowire solar cells. A perovskite solar cell uses perovskite compounds for solar light harvesting. Quantum dot solar cells makes use of nano-sized materials to harvest the energy of the sun. Nanowire solar cells uses nanowires to harvest the energy of the sun to generate electricity.
NASA is going to Moon in 2024, not as a conclusion, but as a first step towards deep space colonization.
But we on Earth are still a Type 0 civilization, blatantly dependent on fossil fuels for all of our energy needs.
Which is degrading our environment, accelerating climate change, and it could render the Earth uninhabitable.
It's high time we have enough technology to move to solar energy and become a Type 1 civilization.